Okay, what we would like to find from this video are characteristics of quadratic function graphs. So we saw in linear equations, the characteristics we wanted to know was what the slope of the graph was and what the y-intercept was. With quadratic functions, there's quite a few more characteristics, and we're not even doing all of them, that we want to know about a graph. Okay, here are the characteristics we're looking for a problem. So direction of opening, up or down, X-intercepts, where it crosses the X-axis, where it crosses the Y-axis, what the vertex is, from the vertex, what the axis of symmetry is, a maximum or minimum value, which is it and what is it, the range, which is related to maximum min, and the interval that it increases or decreases. And so we'll look at all of those with lots of different functions. Let's just start with this one here. And let me just plug in this equation. So y is equal to negative bracket x minus 2 bracket squared plus 5. Okay, let me zoom that out a little bit. There we go. So we want to know all those characteristics about all these problems. And we are on the next video, in the next slides, we'll look at them in relation to the equation. But for this one, I just want to look at the characteristics. So the direction of opening, this one opens down. So the opening is down, the peak is at the top. So this one, direction of opening, I would simply say down. X-intercepts are these points right there. We've just done a video where we used the quadratic formula, factoring, etc., to determine the x-intercepts. You would do that with an equation for that. The y-intercept is where it crosses the y-axis. So it looks like I can figure this one out. It looks like it comes out to 1. So 0 and 1 would be my y-intercept. The vertex is this peak point right there. And if I look at this graph, it looks to be it's hitting it at 2, and I think the top is 5. So the vertex is 2 and 5. From that, we can get the next 2 fairly quickly because that point divides that parabola right in half. And so that line that cuts it in half is known as the axis of symmetry. And it's always an equation of a line, and it's always x is equal to, and it's always whatever the x value is of the vertex. So the axis of symmetry is 2. Also in this parabola, if you take a look at it, there's a top point, a maximum point that it can get to. So this quadratic function would have a maximum value, and that maximum value would be whatever the y value is of that point. Now the range is, and I want to do it in interval notation, is always listed in brackets like this. Should I have a square bracket? I probably should have a square bracket on the last one because it can include that number. Okay, but it's the smallest number to the biggest number. The smallest number, since the graph can go forever down, would be negative infinity. That's as small as it can go. And the highest the graph can go this way, highest going up would be up to 5. So that would be my range. Now the next question asks me to tell an interval for when the graph increases or decreases. So in this first part, and we're always thinking about going from left to right, the first part of this graph, it goes up, 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 till it stops right there. So the graph is increasing from negative infinity all the way till it gets to that point there, which is 2. And we're thinking, when you're thinking intervals, always think x. So left or right. So from negative infinity to 2, that graph is increasing. And then after 2, the graph starts decreasing. So from 2 all the way to positive infinity, the graph is decreasing. So those are the characteristics of the quadratic functions. Now we need to do it with a bunch of different quadratic. Okay, based on what we just did, see if you can figure out what all of these things are from this graph. Oh, it's not graphed. Let me graph it. And you can graph it on your decimals too. y is equal to bracket x plus 1 bracket squared minus 4. There we go, right there. So just look at the characteristics and see if you can tell what they are. And then press play and see if you're right. Okay, I just did it. Compare your answers with what I got here and see if you are correct. Okay, so now what we want to be able to do is to determine all those characteristics right from an equation rather than having a graph with us. And we can do that fairly easily when the graph is written in vertex form. So the vertex form means it just looks like this. So there's a bracket and a squared, and there's a number in front here and one out back. I guess there doesn't always have to be numbers there, and if there aren't, you assume there is 0. So the value of whatever h and k is known as the vertex. So if I'm given the equation that looks like this, my vertex is going to be a positive 3 and a positive 2. Notice I changed that from a minus 3 to a positive 3. Okay, so if that's my vertex, I know my axis of symmetry is 3. My min or max value has to be y is equal to 2. We'll figure out min or max in a second. Range, I guess I have to know the direction to figure that out. Why don't we do that now? So the direction, if this number or if the sign in front of the bracket is positive, it means the graph opens up. Therefore, my direction of opening is up. And if it's opening up, then there's a minimum value. And the minimum value will be 2. So the range will be, the smallest number will be 2, and the highest number will be infinity. And I can put brackets around that. It can equal 2, so I can put a square bracket there. Okay, X-intercepts, again, I'm not going to focus on those here, but you would have to multiply all this stuff out or try and use the square root principle, but all of that stuff we did in the last video. Let me show you quickly, though, the Y-intercept. To determine the Y-intercept, you put a 0 in everywhere you see an X. So in this function that I have there, I'm just going to do it over here. I'm going to put in a 0 everywhere I see an X. So 0 take away 3 squared plus 2. So 0 take away 3 is negative 3, so it'll be negative 3 squared plus 2. Negative 3 squared is a positive 9 plus 2, so that's going to be equal to 11. So the y-intercept will be 0 and 11. Now the intervals, now that we know that the graph goes like this, and that point there is 3 and 2, intervals focus on the x value. So from negative infinity all the way up to the x value, one thing happens, and then from that x value to a positive infinity, something else happens. So in this case here, the graph is coming down, and so the graph is coming down, and it does that from all the way from negative infinity all the way up to positive 3. But then at positive 3, the graph changes and goes back up. So the graph's going to be going up all the way from 3 to positive infinity. Okay, let's just confirm that what we have written down here, other than our x-intercepts, are correct. So let's try and graph this. I'll just bring out decimals here quick. Hopefully it'll work for us. All right, so I have to go y is equal to bracket x take away 3 bracket squared over plus 2. Okay, take a look and see if we're correct. Is the vertex 3 and 2? Sure looks like it right there. The graph is going up like we thought. This is an interesting, when you look at the graph here, this tells you something about our x-intercepts. In this case, it doesn't cross the x-axis, so there are no x-intercepts. There's none. Okay, why don't you try one? Go ahead and try this one. I'll fill it out, and you can see how you do. Okay, I've gone and completed. I didn't check my answers. Hopefully they're right. I found the vertex to be 3 and 1. The graph looks like that's right. The y-intercept, if you look way down there, y-intercept being -8, yeah, that's what I got. Axis of symmetry, oh, I got that wrong. Because the axis of symmetry is always this number. Darn, I got one wrong. So as x equals to 3, it has a maximum value of +1, and from -infinity all the way up to 3, all the way up to there, the graph is going up. And then from 3, it starts falling. So it falls from 3 all the way to +infinity. Now this one's sort of a nice one because if you look up, I've sort of drawn on the graph, but you can look right here and you can tell what those x-intercepts are. So I think they're 2 and 0, and then 4 and 0. Okay, so that's how you can tell the characteristics of a graph if it's given to you in the vertex form. But there's another form, standard form, that you can use to determine those characteristics as well. So here this is the standard form, and it's a form we've seen before. The direction of opening right off the bat, since this is positive, I can say this graph is opening up. It's going to look like that. X-intercepts, I could, well, why don't I do that? I can factor this one. So I think it's x minus 4, x minus 2. Oh, I think it's the question we just did. So if that's equal to 0, then either x is 4, so 4 and 0, or x is 2, so 2 and 0. So those would be the x-intercepts. The y-intercept is always this last number in standard form, so that's 8, got it. Vertex, yeah, I don't know that. Axis, the rest of it I don't know because I don't know what the vertex is. So to figure out the vertex, one thing you can do is to change that form into this form, the ax minus 8 squared plus k. So you can do that, or you can use a formula, but we'll do that in a second. So to complete the square, or to change this to the vertex formula, we use complete the square. But we do complete the square in a slightly different way. Like to compensate, I have to keep things on one side. So what I do is I group these two. So I have x squared minus 6x. I'm just going to leave myself a little bit of room there. Plus 8. And then I'm going to complete the square. So the minus 6 divided by 2 is minus 3. Squared is positive 9. So positive 9. But if I add 9 there, I have to compensate for that somewhere. And what I can do if I'm on the same side of the equal sign, I can just say subtract 9 outside here. Now, if there's a number out front, that complicates that. So you have to be careful with that. Okay, continuing on, if I factor this, this will be x minus 3 squared. 8 take away 9 is a -1. And now I have this function in the proper form. Then I can say, well, my vertex is 3 and -1. My axis of symmetry is x is equal to 3. My min or max value is going to be -1. And I can complete the rest of this stuff. And we've done that on other questions. But this piece here, the completing the square, is the part that's a little bit tricky. Okay, why don't you try one? Complete the square with that and see if you can determine what the characteristics are. Okay, I think I've done these. So I think that the vertex is a -2 and a -9. Let me just confirm that. Let's pull up Desmos and see what Desmos says. Oops. Okay, well, it's a little small. I'll just cover some of the stuff. Okay, y is equal to x squared plus 4x minus 5. Okay, good. So that point right there is -2 minus 9. Yes, got it. X-intercepts, 1, 0. Yep. -5, 0. Yep, good. And I think all the rest would be the same. Okay, so hopefully you had a similar thing. Now, it turns out that completing the square is one way to do it, but there's also another way you can do it, and that's using a formula. And typically, students find the formula a little bit easier to do. So this is the formula right here, and you'll be given this on the test. And it's just basically a ordered pair. So the first part is the x part. So to figure out the x, you do that. To figure out the y, you do that. And let me explain how those work. So you look at this one, and to complete the square, there's some negative numbers. There'd be a number out front. Might be fairly complicated to do. You can do it. But using the formula is a little bit easier. So to figure out the formula, the a is the thing in front of the x squared, like usual. B is the thing in front of the x, and c is the constant term. We actually don't need the constant term to figure out the x part anyway. So to figure out the x part, you figure out what minus b over 2a is. So minus, okay, b is a negative 6 over 2 times a is a negative 2. Okay, so negative 6 would be positive 6 over negative 4. If I simplify that, that'll be negative 3 halves. So that's the x value of the vertex. Let me just look at that and make sure that's right. Yeah, it looks right. Okay, so that's the x value. So if I'm looking for the vertex, that x value is negative 3 halves. Over here, negative 3 halves. Axis of symmetry, negative 3 halves. Now, if I want to know what the y-coordinate of the vertex is, I do this. So I figure out the value of the function when I plug in a minus 3 halves everywhere I see an x. So it's minus 2 times minus 3 halves squared, minus 6 times minus 3 halves, minus 5. Okay, that's a fairly big one. I would just plug that in your calculator. I'm going to press pause and do that. You do it too. Okay, I think I figured it. Hopefully I did it right. The y value came out to negative 1/2. So that is the y value of the vertex, negative 1/2. That'll be, in this case, because this is negative, the graph is upside down. So the graph opens down. The y-intercept is this number here, negative 5. X-intercepts, I'd have to do the whole factoring, quadratic formula, whatever for that. It's going to have a maximum value, because you can't get any higher than that, of negative 1/2. So the range would be, the smallest number would be negative infinity, and it could get you all the way up to negative 1/2, including negative 1/2. And then the intervals, the graph is going to be going up, and it does that from negative infinity all the way up to this value, negative 3 halves. And then from negative 3 halves all the way to positive infinity, the graph will be going down. Okay, so that's how you can use the quadratic, or not the quadratic, the vertex formula to figure out the vertex. Okay, why don't you try this one using the vertex formula and determine what all those characteristics are. I'll maybe do this one by video too, instead of just putting in all the values. So to get the x-coordinate of the vertex, it's minus b over 2a. So minus b over 2 times a. So b is this number, 4. All over 2 times a is 2. So this would be minus 4 over 4, or a minus 1. So the x value of the vertex is minus 1, axis of symmetry is minus 1. The intervals will be something negative infinity to minus 1, and from minus 1 to a positive infinity. Maybe I'll just do the intervals now. Since this value is positive, the graph opens up. So the first part is going to be going down. So as I come this way, the graph is coming down, and then it stops there and starts going back up. So this will be going up. Okay, quite a bit of stuff just finding the x-coordinate of the vertex. Now to figure out the y-coordinate of the vertex, I found the value of the function when I plug in what I just got into this equation up here. So it'll be 2 times negative 1 squared plus 4 times negative 1 minus 7. Negative 1 squared is positive 1 times 2 is 2. 4 times negative 1 would be a negative 4 minus 7. 2 take away 4 is negative 2, minus 7 is a minus 9. So that's the other coordinate of the vertex, minus 9. And so that's going to be a max or min value. Since the graph is opening up, there's going to be a minimum value. And so your range, you're going to start at your minimum value, so it'll be a -9, and it'll go up to positive infinity. Oh, there's a square because it can include -9. Okay, the y-intercept is this number right there, -7. The x-intercepts, with this one, I'd probably try and factor. I don't think factor would work, so probably the quadratic formula. And the direction of opening is up. Okay, so now hopefully you're feeling fairly comfortable with that formula, because we can do some worded problems that it's easy to use the formula to figure them out. Here's two of them. All right, the sum of the length and width of a rectangle, 69. Find the dimensions for which the area is a maximum. Okay, as soon as I say the word maximum, I'm thinking vertex, because it's going to be something up there, or, well, it has to be that one, not this one, because this would be a minimum. So it's going to be a parabola that looks like that. So when I write my parabola, it's going to have -x² and some stuff. Okay, so let's see if we can figure this out. So the sum of the length and the width of a rectangle, 69. So length plus width is 69. Find the dimensions for which the area is a maximum. Okay, well, the area of a rectangle is length times width. Oh, there we've got two equations in the same variable. Let's change this one so I'm solving for one of the variables. So let's subtract w on both sides. So I have L is equal to 69 minus W. Now I'm going to plug this in wherever I see a L in this equation down here. So area is equal to 69, oops, 69 minus W times W. Okay, now distributive property, so 69W minus W squared. Let's rewrite it. So it's minus W squared plus 69W. Notice the minus sign right there? That's what I was saying over here. Okay, so now I need to find the dimensions of this thing. So to find the dimensions, what I'm going to do is I need to find the vertex. So to find the vertex of this, I'll use this formula right there. So the vertex, I'll do it over here. So the x-coordinate of the vertex is minus b over 2a. So minus b over 2 times a. B is 69, and a is -1. So 69 divided by 2, I think is 34.5. Is that right? Yeah. And positive 34.5. So what I was solving for here is W. That means for the vertex, this 34.5, that number there, is the width of that particular rectangle. Now, if I were to proceed and figure out this next number of the vertex, this would be the area, because that's what I'm solved for here. That would be the area. And I could do that. I'm not sure what it'll be, 900 or 1,000 or something. But the question that just asks for what the dimensions are. So if I know what this is the width, I can plug that back into this formula to figure out what the length is. So 69 minus 34.5, and it'll turn out to be 34.5 as well. So to get a maximum area with a four-sided figure, basically has to be a square. So 34.5 for each. Okay, so I use the vertex formula. If they use the word maximum, think vertex. Here's one more where they do this. All right, in this question, we're asked to find when a ball reaches its maximum height and what that actual height is. And they give us this function here, and they say what time and what height. This will be my time, this will be my height. So I just have to find the vertex. So to get the x-coordinate of the vertex, it's minus b over 2a. So minus something over 2 times something. The b value is 20. all over the a value is minus 16. So when I figure this out, it'll be 20, positive 20 over 32. I think 4 will go into each of those, so it'll be 5 over 8. So at 5/8 of a second, that's when the ball is going to reach its height, or its highest height. Let me just put that over here. So the vertex, 5/8 will be the time. And now to figure out what the height is, let me plug that back into the function. So h at 5/8 will be equal to negative 16 times 5/8 squared plus 20 times 5/8 plus 6. Okay, so multiply all that out and that'll come out to what your height is. I'm not going to do that, but that's sort of the way you do the question. Okay, so in this section, we have looked at characteristics of quadratic functions. We've looked just briefly at X-intercepts. We did that in the last unit. But we also saw quickly I can determine Y-intercepts by plugging a 0 in for X. And we have also found a bunch of other characteristics that we get by determining the vertex of the problem. Try the video quiz, try some questions.